So I'm going to jump into the presentations that were given. The way we structured our conference was from low in the food web to high in the food web. So I'm going to start with all those small critters out there that are the basic building blocks in our food web. So this talk is going to focus on some of the key nutrients that aquatic ecosystems need, as well as some of those small organisms. There will be some slides that show comparisons against other Great Lakes for some context. This slide portrays phosphorus levels since the early 1980s in Lakes Huron, Michigan, and Superior. And the thing to note here is that we're seeing phosphorus declines in Huron and Michigan, and no real trends, no changes in Superior. And those blue and red lines, the red line indicates the average for Lake Superior, and the blue line indicates the average for Lake Ontario. So some additional context. So the story here is Huron's declining, and our phosphorus levels are actually below the average for Lake Superior. Phosphorus is important because it's the limiting nutrient in aquatic ecosystems. It's like nitrogen on land. If you don't have a lot of phosphorus, you don't get a lot of production in your food web. It's about as simple as that. Some other indicators of productivity outside of what's happening with phosphorus are chlorophyll. Chlorophyll is just a surrogate for the organisms called phytoplankton. They take sunlight and convert it into growth. So phytoplankton are that very basic group of organisms that are grazed by plankton. So they're the ones using those nutrients like phosphorus and sunlight and putting it into growth. So the story with chlorophyll, again, a surrogate for productivity, is that we've seen big changes in the early phytoplankton blooms, which chlorophyll's indicator of. The dark green indicates what happened in '99. So normally you see a spring bloom when the lake turns over after ice out before stratification. So you have nutrients locked up deep in the water column. They're redistributed. You get phytoplankton production in the spring. And then you get it again in the fall when the lake turns over again and unstratifies as the lake cools down. So we've seen, an almost absence of spring bloom of phytoplankton in parts of the lake, and a reduction in the magnitude of the fall bloom. So that, again, is another indication of declines in productivity in the lake. So you jump up kind of a level in the fish community, still, small organisms in the lower trophic levels. All of these various graphs show densities and biodiversity in the plankton community. So zooplankton, you're jumping up in the size of the organisms. Zooplankton are now, these are the organisms that prey fish feed upon, as well as juvenile game fish. So the story for Huron is that we've seen major declines in abundance through time, and we're now actually, in terms of zooplankton abundance, very similar to Superior again. So in a number of different ways, Lake Huron's actually become a lot more like Lake Superior than it used to be, and Lake Superior is the least productive of the 5 Laurentian Great Lakes. This talk also included some additional information about Diaperia, and as Dave mentioned, a very key organism in the movement of energy in the open water portions of the lake. So this critter lives near the surface of the sediments, and at night they actually come out of the sediments and migrate up into the water column, and that makes them available for consumption by fish. We've seen dramatic declines in Diaperia in Lake Huron, and that's had some cascading effects for benthic species like lake whitefish, but it's pretty dramatic impacts to the availability of lipids in the fish community with their decline. Last slide in this chunk of the presentation is some information that shows the increases in abundance of quagga mussel, one of the invasive mussel species. As Zebra mussels were the first invasive mussel species to colonize the lake. Quagga mussels have actually taken over, and they're actually numerically more abundant now because they have the ability to colonize soft substrates, hence deeper portions of the lake, whereas zebra mussels are a colonial mussel species on hard substrates only, which are available near shore primarily. So quagga mussels have actually usurped zebra mussels and are more abundant numerically and on a spatial way because they can colonize the entirety of the lake, whereas zebra mussels are confined near shore. So some basic conclusions out of that stuff, we've seen declines in total phosphorus concentration, so we're actually below superior, and that has consequences for overall productivity. Spring chlorophyll levels show the same story. We've seen changes in our plankton community, and Diaperia are gone from the majority of the shallow sites, shallower than 90 meters in Lake Huron. They're stable at deeper sites, but stable at lower levels than they were historically. Does anybody have any questions about lower trophic levels before I jump into prey fish? All right, I'll carry on. This is a talk given by USGS in our symposium. This is based on their surveys in the main basin. This is a bottom trawl survey. They also do a hydroacoustics and midwater trawling survey, but they only provided information from the deep water trawl. These denote the transects or the sites where they sample with this particular survey in the main basin. And not a lot of surprises to those of you that are interested in the offshore fish community. Starting in 2002, and it was very evident by 2004 that we had an essential alewife collapse in Lake Huron. This data is only for the main basin, but it's largely a story told for all three basins with this species in particular. Note that between these two graphs, if I could go back, the scales are different. So alewife within the time series were more abundant than smelt. Note the differences in the y-axis, so not as many smelt historically. We have seen smelt decline through time. That's largely a result of predation. And there is some signals that smelt have the ability to reproduce themselves after alewives decline. So we have seen some signals of increases in smelt biomass, but certainly not on a scale of replacing what used to be present in alewives out there. Some of you may have seen this graph before. This is the whole time series for all the species that they track in that survey. So pretty precipitous decline in overall prey abundance, depending on how you analyze the data. We're somewhere near a 75 to 90% decline in total biomass versus the prey community at its peak within this time window. So, this obviously has some pretty drastic consequences for predatory fish. There just isn't as much prey out there as there used to be. So, again, just to summarize, alewife and rainbow smelt abundance is low. It's dominated by small fish for most of those species, which is, again, important for predators. Small fish don't represent a very high quality meal. Bloater biomass, this bloater chub that Dave talked about, their abundance is actually increasing. They're the species that is showing some signs of increase the last few years. Other prey species, their numbers are quite low. We did see an increase in the last few years from 2010 to 2009, but it's still the second lowest estimate of lake-wide biomass, all species combined on record. And surprisingly, around goby abundance, although it had come up in our last state of the lake reporting period, it's come down since, and it's actually relatively low, as shown in this survey. Any questions on the prey community?
How are you measuring the number of gobies when you can't do a bottom trawl where the gobies exist?
That's a really good question, Jake, and that's one of the things that we are challenged with our prey assessment. I am actually glad you brought that up. We know we are largely inadequately sampling brown gobies. Michigan is actually initiating a new program near shore in their waters to try and deal with that question. We have a small fish survey, and I don't have any of the data in my presentation that does give us some insights into brown goby dynamics, maybe better than that bottom trawl. The bottom trawl captures a lot of the other species reasonably well, and it's useful for them. Not as useful for round goby, given, as Jake mentions, they inhabit nearshore areas, rocky substrates that you can't bottom trawl very effectively. Bottom trawling is largely suited to smooth or soft substrates because you can hang your trawl up and lose your gear if you're trying to do it on hard rocky substrate.
That said, though, they're doing the same trawling every year, so they should be able to get some idea of abundance or changes in abundance.
Yeah, it gives us some sense in terms of trajectories and population abundance, but I wouldn't necessarily say the actual abundance numbers or biomass numbers are wholly indicative of what goes on with round goby.
Yeah, because they can get right down in between the cobblestones and you just can't catch them.
And they're fairly sedentary species as well, and territorial.